Are you trying to figure out how to build an avionics bay for your high-power rocketry project? Join us and we'll go through our steps and our missteps, and hopefully you'll find something helpful for your project. We're going to start by putting too much wood glue in and then adding the stiffener tube to the middle. And then once we have that cleaned up a little bit, we're going to grab the end caps and just make sure we have it properly centered and the depth set right on both sides there. We're going to pull those out and then clean the glue down. And then the next step will be to take the switch band and glue it into place. So we'll put, again, copious amounts of glue there. And we'll make sure to twist it there just to get nice even coverage. We'll clean up the mess. I'd rather waste glue than not have a good attachment. And just in case it's not obvious yet, the switch band is just a normal piece of airframe that we've cut down to be pretty short, and we'll glue it in the middle there. With that, we're going to go with a sort of step-down shouldered version of these end bulkheads. I have put a bevel on the downward sides of those just to make sure they can line themselves up easily and go on. I do have access to a laser cutter that does make this part of the process a lot easier. But as we'll see through the rest of the video, I didn't want to do the whole thing as a CAD exercise. So we're going to figure out as we go where we really want things placed and how to lay them out. One idea we had early on is I wanted some sort of protection from the deployment gases. So I tried this polyamide tape. It's non-electrically conductive. It's meant for high temperatures, but it's sort of meant for electronic versions of high temperatures. So after we put this on, I did take a torch to it just to do a quick flame test, and I wasn't really happy with the results. It's just not the same type of high temperature. So that didn't work out. What we are going to do is we're going to switch to a high temperature flue tape here. It will definitely hold up to the heat, but as we'll see in a second, it is entirely conductive. So we want to make sure that we sort of protect the wires and that we don't wear through and short out with it. It, again, shouldn't really be a problem. I was just hoping for a different option. And here we can see the multimeter definitely reading conductive. And since we're keeping this approachable and we've already used a laser cutter, so we're going to go ahead and throw the metal bandsaw at this and cut down that threaded rod to size. Then we're just going to do a quick dry fit, see if we think the overall lengths are sufficient. It's always better to fail early and fail often here. So in this case, the lengths seem okay. And we're going to move on to the charge wells. I thought that the main hazard was that the cap of the centrifuge tubes would poke through the side of the airframe. So I thought as long as I lined them up sort of along the axis of the rocket, that would limit the majority of the damage. As we'll see here and in some other videos, that wasn't really the case. But for now, I wanted to try and use the spent casing of a black powder motor just to hold the centrifuge tube and keep the charge lined up. The next thing we're going to do, as you've seen, is we're going to figure out where we're going to lay out those screw terminal blocks. One thing as we go through, I did want to be able to have redundant charges on each side, and I did want to be able to fit redundant flight computers as well. And then just to keep things complicated, I also wanted dual batteries for each flight computer. I'd seen where sometimes the switches would bounce and cycle the flight computer. I also wanted them to be able to be turned on and configured before they're at the pad. It seemed like a lot to do on the actual pad. So I wanted to have the deployment charges on a separate battery and the safety interlocks on the deployment side of the flight computer. You'll see we don't quite build out both flight computers on this, but that explains the odd spacing that we'll see throughout this video. We're going to jump around just a little bit here, but we're going to cut through the foil and position the charge wells, if you will, and then glue those in place here. We will see I'll end up switching these out, and there is some other problems with this method of attachment. Then we're going to do a dry fit with the sled, and overall we're pretty pleased with the spacing here. Now, we did just epoxy directly to these nylon bushings here. I was wondering how adherence was going to be. It didn't end up working out too well, but we'll take a quick look at that. So we have the slots for alignment and spacing, trying to get that surface area up, but it just didn't work out. So we went back to the laser cutter, cut a different sled with a nice sharp angle there, and wrapped some Kevlar string around it to give some reinforcement. With the deep cut in the sled and the compression that we had, I figured as long as it would stay on axis, it really wasn't gonna slide. out of there, and there wasn't room to do it. So far, it's held up. And we did also put some pretty deep sanding grooves in the bushings, again, just hoping to improve adherence. And then after that sets, we come back and smear a bunch of epoxy on the other side. Make sure to get it nice and in between all those Kevlar strings. Next, we'll see if you solve some of the other problems. The centrifuge tubes do fit in the spent motors, but again, we'll abandon this later. And with the terminal block location all laid out, we'll go ahead and drill a hole there and attach it with a screw. And we'll go around and do that for all 4 terminal blocks. Then with those installed, we'll go back and drill holes for the ignition wires. And then we'll dry fit everything again with the new sled and the hardware on the outside here. Now you'll see I did have the wing nuts, and then I had these screw-on eye bolts. It's probably overkill. My thought would be that I could always back tie to the rod that went all the way through. I had some debate with myself as to whether or not to have 1 rod in the center or 2, but I wanted to keep it lined up with the arming switch hole on the outside of the airframe, so I went with the 2. Of course, it's important to vent your avionics bay to atmosphere, especially if you have a pressure-based altimeter. So we're going to drill 3 holes here and about equidistant around. One of those will also serve as the switch hole. We don't want any parts that are meant to be permanent coming off, so we're going to come back, we'll mix up some epoxy here and just slather that on all of these bolts just to make sure they're nice and solid in place. Now we're going to start laying out for our actual flight computer and battery. Again, keep in mind I did want room to do fully redundant. We won't finish it here, but that explains the layout. So we'll mark the first hole. We'll sort of countersink the nut there. And then I used some plastic standoffs. Felt like plastic was probably the way to go versus metal. Less metal in the airframe maybe gives it a little more give. So we'll mark the remaining 3, come back, countersink those holes again, put the nuts in, and then screw in the standoffs. Once we have that, we'll go ahead and install the altimeter and see how we like it. Satisfied with that, we're going to go ahead and place the limit switches. Again, we're going to do 2. Off camera, I've marked where the switch hole lines up, and I put a bamboo skewer there to act as a guide rail for that. So when we push the other bamboo skewer that will be the remove before flight pin, it'll line up, and these threaded rods themselves will kind of act as a little funnel just to correct a little bit if we're off rotationally. So with those in place there, we'll come back and add some fillets of glue, of course, to that skewer guide rail. Once that's cured, we'll flip it over and go ahead and crank down and secure those limit switches in place. And these limit switches are both default open and default close, and for the life of me, I can't ever remember the pinout. So we want to test and make sure that I remember the actual pinout before we solder and wire these wrong. So we get the multimeter and verify that. Then we'll go ahead and trip the limit switches and make sure that they're behaving as we want and that the other pin is behaving like we expect also. Now we're going to cut the top section of the airframe down to size. So we'll mark that out and just slowly go around and around with the X-Acto. Then we're going to add the coupler, draw some marriage lines, tape it in place, and we're going to drill 3 bolt holes. I guess in theory you could have these equally spaced and have them lined up, but I always just sort of give up and draw the marriage lines. Now we need the holes in the AV bay to be big enough to accept a T-nut so that we can bolt it to the top section of the airframe so that during flight and deployment it doesn't separate, but we're able to take it apart and work on it at the table. So we're going to widen those out, smooth them down a little bit, and then we'll come back here and use some pliers to set those T-nuts in place. And then just add some super glue just to make sure they stay where we put them. And something else we want to stay where we put them are the batteries. So I decided to just try to do zip ties instead of anything too fancy. So I'm going to put a couple holes here so that I can zip tie the redundant batteries to the sled, and then I'll come back and stabilize them the other direction with another zip tie. So just crisscrossed zip ties for the win. We'll say zip ties can maneuver around, and when you cut them, they can be pretty sharp. So I tried to take some care in not leaving sharp bits there. So now we'll come back, we'll add the other direction and lock those in place. Then we'll add our Eggtimer Quantum here. I do have a bunch of video of soldering that together. I haven't managed to make a build video of that, but if you're interested, maybe a nudge would help. But we'll put it in place here just to check our cable runs, and then we'll solder our switches. This was on the positive side of the deployment charge power port, so we went with the red color coding here. So we'll just quickly get those in place. I did want these to be able to be disconnectable, so I went with a JST connector here for this setup. So we'll come back and we'll do the negative side here, just string that together, solder it, and then we'll do everybody's fun part of coming back with a little torch and shrinking the heat shrink. But that'll give us both sides of the switch disconnectable, so we could remove the battery and then we can have the other plug into the altimeter. When I first put the computer together and did the initial testing, I put one of these GST-T plugs on it. When I finally got the batteries that I was actually going to use, that wasn't the connector on it, and they're kind of big and a little cumbersome. So we're going to switch those off here and go back to just the normal GST connector. Then we're going to come back and do the same on the other side. So this takes two batteries, right? You can have one dedicated for the deployment, and then you can have one for the flight computer. So that's why we're doing this twice here, as we need the other side there. So we'll just solder that in place, and of course shrink the heat shrink down. And then hopefully we've measured all the cables properly and everything lines up. The last little modification I'll do here is, again, when I built it for testing, I connected another JST on that so that we could effectively just jumper it by connecting it, and that would put it back into one battery mode. But given our choices now, went ahead and disabled that. After our first ground test, we had a delamination here, so I thought I could get away with just coming back with some super glue and tacking that down. So it stayed on. However, when we did the next ground test, we popped a hole in the side of the rocket. So I decided that some containment lateral, just given how close it was to the sidewall of the airframe, was probably called for. So I found a section of copper pipe and an end cap. We took the end cap out to the anvil, smashed it down flat, brazed these two together, and here you'll see we'll just do a nice firm screw attachment. So off screen, we glued another coupler into the rocket to repair it, and then we did several more ground tests, and they all went pretty well. It being as hard as it was to find motors, I stopped here. So I plan on switching the rest out to copper charge wells here, but I was right at 5-to-1 thrust to weight for the shakedown flight for this. And to try to keep it simple for the cert flight and the shakedown, I was relying on the Jolly logic for the dual deployment type behavior and the motor ejection charge for the backup. So I thought it was safe enough to go forward like this. So that's how we built our avionics bay. Thanks for watching. Catch you next time.